Hello everyone. In my previous videos, we have seen about bag of word, right? It is one of the technique used in NLP for the feature attraction, or we can say converting the text into numbers. But there are some lot of problems with a bag of word. Okay. So in this video, we will understand what are the limitations or drawbacks and why bag of words is not able to capture all the context or negative sentiment, positive sentiments, those things we're going to cover, and what are the alternative or better solution as compared to bag of words like NGram. Those things we will going to cover in this video. Okay, so let's understand. Let's get us started and let us find that why bag of word is not able to handle a lot of situation, a lot of problems, and how the NGram which is next version or advanced version is able to capture a lot of nuances in the text message. Let us see and let's understand NGram in this video. So first of all, let us understand the shortcoming or limitation of bag of word. Why it is not able to capture a lot of context or contextual meaning in a given sentence. Okay, so in order to explain that, I'm using two sentences, very simple two sentences. Okay, so first of all, as you know that bag of word is just a collection of individual words. In the bag of word, what we do, we just count the number of occurrence of the word, right? If you have seen my previous video, and if you understand the concept of bag of word, it just count the frequency of given in the document, how many times any words are repeating in a document. It's just a frequency, right? But it is not considering, this is very important. Okay, just focus over here. It is not consider the order of context, in what context the word are getting used. Okay, and what is the order of word? Maybe in the text, if your order of word play very important role. If we change the order, the meaning of the word or meaning of the sentence get changed. Okay, and if I'm using a word, then in what context it is getting used, right? So this whole this the contextual meaning or the order word, this is not captured by bag of word. It is just a frequency count. Okay, let me explain that. For example, let's suppose we have two sentences. Suppose we have this pasta is tasty. Let's suppose this is my one sentence. This pasta is tasty, and suppose we have to do sentiment analysis. Okay, so if I say that this pasta is tasty, it is a positive sentiment, right? And if I say that this pasta is not tasty, it is a negative sentiment, right? So if we use bag of word, okay, so if you know the bag of word, what it will do, it will create a vocab. Okay, so for this is the vocab, right? This pasta is tasty not. I hope this all thing I have covered in the bag of word. Okay, so I'm not going to repeat that. So for these two corpus, these two documents, what is my unique words or what is my vocab? My vocab can be this: pasta is tasty. This already cover, so this is not, I don't have to repeat it. Pasta already cover, not repeat. Is already cover, not, so not is my vocab size, and tasty, right? So you can see that in these two documents, or into these two documents, this is my unique vocab size. This is my vocab size, right? Now with respect to this vocab size, we will prepare my uh, vectors, or I will try to find the frequency, or I will convert my sentences into number. This is the basic concept of bag of words, which we have already seen there, right? So for example, suppose this pasta is tasty, right? So for sentence one, okay, what is the uh, numbers or vectors or text? So this is there, so that is why it is giving 1. Pasta is there, it is giving 1. Is there, is giving 1. Tasty is there, it is giving 1. Not, there is no not, so it is giving 0. I hope this thing I have already covered, right? For sentence number B, this pasta is not tasty. So for this, the embedding will be like this. This is there, so 1 1 1 1. Not is there in this sentence, not is there, so that is why it is coming 1. Okay, so it's very simple, right? So for the sentence 1, this is the corresponding vectors 1 1 1 1 0. And for B, this pasta is not tasty, the corresponding vector is 1 1 1. I hope this part you cover, this part you understand, right? We have already covered this part. Okay, now if we embed, if we create this kind of numbers from this given text, there are a lot of things are missing. Okay, you can see that that tasty word, okay, that tasty word is coming in the both sentences, in the first sentence and the negative in the second sentence as well, right? So you can see that if you notice this problem, both having the tasty, the count is one. Okay, so here if we build a model, let's suppose if I build this kind of text, and let's suppose I'm building a random forest or any kind of classification kind of model, okay, and I want to find the sentiments. Okay, so what is the sentiment of a statement A? It's a positive sentiment or negative sentiment. What is the sentiment of sentence B? So if you apply Bagger word, the model will consider that because tasty is coming in the both sentences. Okay, it is giving one counting, right? So my model will consider that this pasta is tasty is also a let's suppose this one, my model will understand that this pasta is not tasty, it is also a positive sentiment, uh, because pasta is coming in the both the sentences, and test, you can see that tasty is also coming in the both the sentences. Okay, so tasty having occurrence in both the sentences, so machine will understand both are tasty. Okay, so it is not capturing not tasty at the same time. Okay, it is just capturing tasty in the both the sentences, so it will understand that okay, even the sentence B, which is really a negative sentiment, my model will consider this is a positive sentiment. So this is the problem with Bagger word. They don't capture order, or main is the context. They don't capture the context of the word, whether it's a positive or negative. Okay, this is one example. So here, according to Bagger word, even the second sentence is a positive sentence, though it is really it's a negative sentiment, right? So this is the problem. Okay, so Bagger word, this is the conclusion. Bagger word misses the negation. If you're using something, you have some negative sentiment, you're using some word like does not, so those Bagger word is not able to capture those elements or those dimensions, so it misses the negation and meaning because it ignore the word order and nearby order word relationship. Okay, so for the Bagger word, they have nothing to do with the order. Okay, for example, if I say not testing, right? So Bagger word is not considering the order of the word, whether this not, what is the relationship between not and testy, right? It is not able to capture this relationship, whether not testy, they have any contextual meaning or they have a relationship, they have any order. It is nothing to do that. It is just counting the occurrence, or it is just counting the frequency, right? So because of that, it is not able to capture those of negative sentiments and the word order, and that is why it will not give a good result if you are building suppose suppose you're building a sentiment analysis kind of model. It is not a good practice. Okay, so I hope as of now you're able to understand this limitation, you're able to understand this shortcomings by Bagger word is not ideal. Okay, it really miss all the order or contextual meaning or negative meanings, those things it is not able to capture. Okay, so how to overcome this? So in order to overcome this, we use NGram concept. Okay, so how the NGram works, let me explain that. Okay, so for example here, uh, let me explain this. How it's very simple concept. Okay, intuition is very simple. Okay, so let's suppose I have two words, right? Suppose I have two words. This pasta is tasty. Suppose if I say that this pasta is tasty, right? This is my first sentence. And if I say that this pasta is not tasty, right? So this is, suppose this is my document one, this is my document number two, right? So here in Bagger word, this is my vocab. Okay, I hope this all thing I have covered. This is my document number one, D1. This is my document number two, D2. Okay, so for this document, for this corpus, we have to create a vocabs, right? This is what we have covered in the previous video. So here my vocab is what? What is vocab? Vocab is a unique words, a unique token. This all thing I have already covered. Vocab is nothing but the unique tokens or unique words, which is the part of your given corpus. Okay. So if I prepare my vocab, the vocab will be this: pasta. This is a unique word. Is tasty. Okay, now this is already come. I'm not repeating this because it should be unique. Pasta already covered, is already covered, not. So not is not there, so I'm covering not, right? And tasty already covered. Okay, so this is my simple vocab. It's very simple, right? This is a simple vocab. So what we do in case of bag of word, right? So I'm just repeating everything already we have covered, right? So in bag of word, in case of bag of word, okay, what we'll do, we just, for suppose for document number 1, how we'll convert the document number 1 into numbers and document number 2 into numbers. Okay, what is my document? The first document, this pasta is tasty, and second is this pasta is not tasty, right? So how I will cover that? That's what I have covered, right? I have given that. For example, it is giving, for 1 it is giving 1110, right? And for 2 it is 111, right? This is what it is creating the bag over, right? So this is, it is covering, right? How many? 1 2 3 4 5. I have 5 vocab, right? So it will give 1 1 1 1 0. This is for document 1, and for document 1 it is coming 1 1 1 1 1, right? Suppose this is my vocab, right? So here the problem is, see, the problem here is that my sentence has this word, right? Not tasty, right? In document number 2, this is the word, right? Not tasty is coming in the word. So in my first document it is saying that this pasta is tasty, and in the second I'm saying that it is not tasty, right? So here this bag of word is not able to capture this order, whether not and tasty are, because we are not considering any order, right? So here tasty is different. It's a separate word for the bag of word. Even tasty is different, not is different, right? Let's suppose this one is for tasty, this is for tasty. So machine learning model will understand, because tasty is in the both the sentence, it will say that even second number, which is not, it is positive sentiment. This is what I'm trying to explain, right? But actually in the second document, which is the having this word, the order of word is saying it is not tasty. So this meaning it is not able to capture. The order is, it is not able to capture, right? So how to capture this meaning, like not testing, right? So that is why we have this concept of what is called NGrams. Okay, so what is NGrams? I hope you able to understand now. You able to understand the limitation of bag of word. Okay, so the limitation, just I write. Okay, what is the limitation here? Limitation of bag of word is what? First limitation is it does not understand the order. No order, it does not capture the order, no order capturing. It does not understand the context of the word. Okay, it does not understand the negation of the negative words. This is all the problems. Okay, so if you're not able to understand the context, not able to understand the order, you're not able to understand the negative word, then model will not perform well. This is the problems, right? So that is why we come with NGram concept. So how the NGrams works is very simple. So it creates okay, let me explain that. Okay, so let me write again, okay, so that I will explain again. Okay, mm, okay. So here let me try this so that I can explain it well. So let's suppose this is my D1, right? My D1 is this pasta is tasty. This pasta is tasty. This is my D1, right? And D2 says this pasta is not tasty. This pasta is not testy. Okay, so according to NGram, because here I'm not, because of in bag of word I was not able to capture the negative word. Okay, the order negation, it was not able to capture. So NGram, what it does, it create a combination of words. Okay, how it creates? So in case of NGram, how it create the vocabs. Okay, the vocab, I'm trying to create the vocab. Okay, so in case of NGram, it combines. It is also called augmentation. Technically, it is called augmentation. Sorry, augmentation. Augmentation of word. Okay, or combining the word. In the layman term, you can say we are combining the words. Okay, so here what I will do here in this case, I will combine. Suppose I'm combining two words. That depends how many words you want to combine. You want to combine two words, three words. This totally depends. Okay. So let's suppose I want to combine this pasta is one vocab. Two words. Okay. So let's suppose I'm combining two words. Okay. So I'm combining this pasta. Okay. Then pasta is. Then pasta is this combination. Pasta is. Okay. And then each tasty. I'm just combining two words. Okay. In my vocab, each tasty. Right. This is for D1. Okay, from D2, this pasta. Right. So this pasta already I have taken, so I'm not going to repeat that. Pasta is, I'm combining. Pasta is already covered, right? It's already there. I'm not going to again take it. Is not, I can combine. Is not there, so I can take is not. Is not, right? And after that, not testy. Not testy. So I'm taking not testy, right? So this is my vocab. Not testy. Okay, so this is the this part is the vocab of my given documents. Okay, so what is my vocab? This pasta is tasty, is not tasty. Okay, so you can see the difference, right? In bag of word, my vocab has only single word. This is my this is my vocab, right? This is the vocab in case of, this is the vocab in case of bag of word, right? This is in bag of word. This pasta is tasty not. So here, nowhere I'm capturing the order. You can see that. For example, not tasty. This is one word, right? Here I'm nowhere I'm capturing not tasty as a single word. I'm not capturing any word order, right? I'm just taking single word and I'm just taking their occurrence. Okay, but here in the NGram, I'm combining two words. Okay, and based on these two words combination, I'm building my vocab. This is the only difference between how the vocabs are get created into bag of word and in case of NGrams. Okay, see this NGrams is, n is a number. Okay, so it can be 2 gram, there are multiple, it can be 2 gram, it can be 3 gram, it can be 4 gram. That depends, this n depends that how many numbers, how many words. Okay, so here n depends how many words want to combine to build your vocab. To combine. Okay, how many words you think I should combine to build a vocab? It can be 2 words, it can be 3 words, it can be 4 words, that depends. Okay, so this and based on that, it is given a name like bigram. If you're combining 2 words, for example, in this case, I can say that it's a bigram. I'm using a bigram technique. It is called bigram because it has 2 words. Okay, so it can be 3 gram, okay, or 4 gram, depending upon the words you combine. It's very simple. Okay, I hope you're able to understand the intuition what I'm trying to do here. So why I'm combining these 2 words? What is I mean, how I'm solving the problem? Because in here you can see that I'm capturing the order, because not testy is coming, right? I'm able to capture not and testy. So here I'm getting the order of word. Okay, and also I'm able to capture the negation. This is very important. if anything which is negation or negative, I'm able to capture. So suppose if anything, if I say that not tasty, only just looking at not tasty, I can predict it is a negative sentiment, which is not possible in the bag of word, because in the bag of word, nowhere I'm capturing the order. I'm not capturing this kind of contextual meaning. I hope you're getting the point. Okay, so this is the whole intuition of NGram and what problem it solves. Let me understand. Okay, let me recap. So in the bag of word versus NGram, I hope now you guys are able to understand the intuition, right? So in bag of word, there is no order. I'm not considering any order. Here I'm taking order. I'm considering order while my building my vocab. This is one difference, right? Second difference, I'm not capturing any negation. No negation capturing. No negation word or capturing. Here I'm capturing negation, right? Here I'm capturing, here there's no any context, no contextual meaning, or I'm not any taking any context of the word. But here, if I combine, okay, if I combine two words, three words, then there's a chance that I can capture context. This is the most important we can say pros or benefit of using NGram. You can somehow, you can consider, you can capture some context. Okay, some context. So this is the difference between NGram and bag of word. Okay, so that is why NGram is I would say more powerful as compared to bag of word, because bag of word is just considering the frequency or number of the word in given vocab, but it captures a lot of things. It captures order, negation, and context, and these all things. Okay, that is why it is more powerful. Okay, so this is the whole idea. I hope you got it. So the only the difference is while building the vocab. Okay, let me repeat. So in the bag of word, we just create our vocab by taking single word, which is it is missing order, it is missing the context, it is missing the negation. A lot of things is missing. Okay, and in NGram, while building the vocab, we combine two words or three words, that depends. Okay, and this way it is able to capture order, negation, and more context. And this way your negative sentiment, your sentiment analysis will give better result in case of NGram, right? So guys, I hope you're able to understand the intuition. This is the basic concepts. So that is what I'm written here in NGram. Okay, what is the advantage of using NGram? It preserve the word sequence. I explained, right? We preserve the word sequence because we are combining words. Not testy is not. So somehow it is able to capture the orders or sequence, okay, by combining the n number of words. Okay, for example, if you use for suppose n is 2, I mean it is a bigram, so I can combine two words. For example, this pasta, this is already covered, right? So for example, not tasty. So in my vocab, you can see that in my vocab I'm able to capture not tasty. So this not tasty is giving me a lot of bunch of idea. Okay, so if we detect not tasty as a unit, it is coming as a unit word. Okay, which clearly says that it's a negative sentiment, right? So by capturing this kind of context phrases, NGram improve the model, because in the bag of word, it is just a sequence, it is just a frequency. We are not capturing any order. So here we are capturing the order, this kind of word. Okay, so it will improve the model and your model will give better prediction, especially for things like negation, idioms, phrase based meaning. Okay, so this is what it is important. Okay, so I hope you got the whole context. So this is whole the meaning, this is the whole the concept is NGram is able to capture a lot of the orders, negation, and the sentiments. Okay, and how it works, just we combine while creating the vocab, we combine words. It is also called augmentation, and this way our vocab size will increase. Okay, you can see that in my bag of word, what is my vocab size? 1 2 3 4 5. Okay, in the bag of word, my vocab size is how much? Number is 5. I have a 5 vocab in my bag of word. But if we combine multiple words, my vocab size will increase, right? So in this case, I have 1, 2, 3, 4, 5. Here it is also 5. But let's suppose if I combine three words. If you combine more words, 3 words, 4 words, your number of vocab will increase. So generally in NGram, our vocab size are more. Okay, that depends, even depends upon number of documents. Okay, so this is the whole concept. Okay, now let us understand how to implement that. What is the library or machine learning package or library which we can implement the NGram, right? So as of now, I hope you have the understanding what is NGram, what is the limitation, and what is the advantage, right? So here for your just for sake of demonstration, I have created one kind of uh, data frame just to illustrate, just to describe this. Let me run this. Okay, so this is my data frame, right? Okay, and I have just two column. One is the text. This is my text, and here based on the text, I want to give some sentiment. Okay, if it is 1, then it's a positive sentiment. If it is negative, 0, then it's a negative sentiment. For example, if I say that this pasta is tasty, then output is 1. This is my label. I have done the labeling of the data. Okay, I hope you understand this whole part. This is just a machine learning classification problem, and I'm saying that this pasta is not tasty, then it's 0. 0 says that it's a negative sentiment. Okay, pasta is delicious, it is 1, positive sentiment. I like I like pasta very much, it's a positive sentiment, 1. Pasta is good, but cost is little high, it's a 0. Okay, it's kind of negative sentiment, right? If somebody is giving this kind of review in, suppose, in your hotel or restaurant, is saying that pasta is good but cost little high, that could be of some concern or some negative kind of feelings, right? Pasta taste is good and affordable. It's a positive sentiment. Pasta taste is really nice. However, price is not. It's a kind of negative, right? So this is what I have prepared data, very sample, very small data, and I have given a label, right? So now let us solve this problem using NGram. Okay, the same thing I did in my previous video where I show you how to use bag of word. The concept is pretty much same. The logic is pretty much same. Only approach is but different. Okay, so implementing the one thing for bigram, for bag of word we use count vectorizer, right? Even for the NGram, if you want to combine multiple word, if you want to capture the order, sequence, negation, we use the same API or same library, count vectorizer, but here we pass some additional parameter. Okay, so if you see the documentation and count vectorizer, it has this parameter NGram range. Okay, so if we pass the NGram range, then you can create NGram. I mean, it will create, while creating a vocab, it will combine words. This is what the NGram does, right? While creating a vocab, we combine the words. So how many words you want to combine, that you can control by this parameter. Okay, that you can configure. Okay, if I say NGram range, okay, it's a 1 to 1. Okay, one thing, so it has a range. Let me explain this API. It's very simple. So it has this parameter NGram range. Okay, so if I say range, if I give this parameter range, and if you say that 1 comma 1, okay, and if I say range 1 comma 2, if I say range 1 comma 3, okay, or if I say range, so these are some this is what we pass in the uh, count vectorizer. If I say 2 comma 2, okay, so range 1 comma 1, what does mean? It means that it will combine, while creating a vocab, it will combine single word. So if you combine single word, what it means? It's a bag of word, right? So in bag of word, our combination is single word, right? So NGram 1 comma 1 is equal to bag of words. Okay, so here we are combining single word, that is why it is a bag of word, right? If I say NGram 1 comma 2, it means here I'm combining two words, just like I show example, right? I'm combining two words, right? So this is 1 comma 2, and also you can see that I have two things. I have 1, I have 2. Okay, it says that I will combine single words. I will take single words. Okay, plus I will take two words while building my vocab. Okay, if I say 1 3, so I will take single word plus I will take three words to build my vocab. Okay, here if I say 2 2, okay, so in this case if I say 2 2, I will take only two words to build my vocab. Okay, so you can see that in this case I'm just taking two words, right? This pasta is, so basically it is here in this case, this example is for what? This is for 2 2 case, right? Because I'm just taking two words to build my vocab. Okay, so in case of, let's suppose this is my, I mean, let's suppose I'm giving this example. Okay, suppose this is my sentence, right? This is my D1. This pasta is tasty. This pasta is tasty. Okay, and my D2 says this pasta is not tasty. Okay, this pasta is not tasty, right? So if I say n1 1 it's just a bag of word, right? Simple. I will take single word. If I say 1 comma 2, if I say if my range is 1 comma 2, let me explain that. If I say range, if I'm taking range 1 comma 2 and I'm building the vocab, let's suppose I want to build my vocab, right? So in the vocab, what can be the combination? So here I'm taking single word, okay, and also I'm taking two words, right? So here for single word, so it will, my vocab will be like this. So for, let me think about for a single word. This pasta is tasty. Okay, so here this is one word, pasta is one word, is tasty one word. This already I have taken, pasta already taken, is already taken, not. So I will take not here. And tasty already there, right? So this is single word, right? This is the single word. Now I have to take two words also. So two words, I mean, I will combine this pasta. So in my vocab, another element will be this pasta also. So I have to take single word as well as I have to take two words. Okay, so it will be this pasta and it will be the pasta is and is tasty. I hope you're getting it, right? So this pasta, by combining these two words, pasta is, by combining pasta is tasty, by combining is tasty. Okay, now again for D2, this pasta already taken, pasta is already taken, is not. So I will take is not one unit, and not tasty. So not tasty one unit. So in case of NGram 1 comma 2, your vocab will be this. This is your final vocab. So it has combination of one word, single word, and combination of two words. So this will be my vocab size in case of NGram 1 and 2. Okay. Similarly, if you say NGram 1 3, okay, if you say I'm taking NGram range, suppose this is my range, I'm saying 1 3. Okay, so it will take all the one, I mean single word. Okay, and additionally it will take all, it will combine three words. Now here it will combine three words, I mean like this. So here it will combine this pasta is, so this three word is one unit now. Okay, so in the three word, let me again write it. Okay, so if I say that let's suppose this is my D1, this pasta is, it's very simple, this pasta is tasty, right? And I'm D2 saying this pasta is, so this is actually only difference is while creating the vocab. Okay, that how it will create the vocab, that will depends upon this parameter. Okay, this is the only difference. Okay, so if I say 1 3, so obviously all the single word, this pasta, this will take, along with that it will take three words. Okay, it means this pasta is three words combination, is it is one unit. Then pasta is tasty is 1 unit. Okay, then is pasta, there's no, okay, so this pasta is 1 unit, then pasta is tasty 1 unit. Okay, then this pasta is already taken, then pasta is not 1 unit, is not tasty is 1 unit. So it will combine 3 words, and it will make 1 unit out of 3 words. I hope you're getting this whole point. Okay, similarly, if I increase the size, okay, if I say 1 comma 4, if I say 1 comma 4 range, so again it will consider all the single word, and then it will combine the whole 4 words. So this pasta is tasty, that's a 4 word, right? So this pasta is tasty is 1 unit now, right? This pasta is not, so this pasta is not a single unit now, and pasta is not tasty single word now. Okay, you can see that if I do 4 combination, so what is my vocab size now? In case of 1 comma 4, my vocab size will be like this. I'm combining 4 words, right? So this pasta is tasty, this is 1 unit. Now this pasta is unit, it is a 4 word, right? Sorry, this pasta is tasty, this pasta is tasty. So this is one single unit. So it is combining 4 words and creating 1 unit. Okay, so this is the part of my vocab now. And for the second sentence, this pasta is not. Okay, so it will come, this pasta is not, combination of 4 words, right? And then pasta is not tasty 1. Okay, so it will say that pasta is not tasty. This is the my third vocab. This pasta is not tasty. No, pasta is not, okay, there will be not this. Okay, there will be no, this is not required. So pasta is not tasty. Okay, it's 4 word. Okay, so you can see that if I go with 1 comma 4, it is giving me more context. Okay, so if the sentence had this vocab, okay, uh, okay, if my sentence had this vocab, pasta is not tasty, it is a negative sentence, right? It's a negative sentiment, right? So it is capturing more context, more order, and it will give you more better result. Your accuracy will be better in this kind of cases. Okay, so this is the concepts, my friend, how we use NGram. Okay, and how to use it in code wise. We have to use count vectorizer, and there's a parameter called NGram. We pass a range, we have to give a range. Okay, so if I say 1 comma 1, so 1 comma 1 is basically bag of words. I'm just taking single word, which is bag of words. Okay, so you can see that here. Okay, let me run this, then you will get the pure understanding. So now here I'm creating a count vectorizer with range 1 to 1, and I'm fitting my text. This is my text, right? I want to convert this text into vectors. Okay, using this count vectorizer. So if I create this, okay, I'm fitting this word, and if I see the vocabulary, the vocab, this is the only difference is the vocab. Okay, how your vocab will be created into if you're passing different parameter. So if you're passing 1 comma 1, your vocab will be, you can see that in the vocab there's just single word, just like a bag of word. It is bag of word in case of 1 comma 1. Okay, this is 1 to 1. Okay, let's suppose I'm using another count vectorizer with the range 1 comma 2. In case of 1 comma 2, I discussed, right, it's a combination of both single word and combining 2 words as a single unit. Okay, you can see that what is the vocab? This pasta is tasty, it's a single word, and it is combining two words. This pasta is tasty, not a single word, is no. You can see that it is combining both single word and two words. This is what I explained in the whiteboard, right? This is what, suppose if I say 1 comma 3, so it will combine single word. You can see this pasta is tasty. Okay, and also it is combining 3 words. Okay, you can see that pasta is tasty, okay, is not, okay, it is combining 2 also. Okay, it is combining 1 and 2 and 3. Okay, so it is, okay, in case of 1 3, it will combine 1. Okay, it's a range 1 2 plus 3. Okay, so it will take 1, it will take 2, it will take 3 also. You can see it's combining 3 but if I say only 3 okay, this is very special. Okay, so in case of 3 it will consider only 3. It will not take 1 2 Okay, it will take only three pairs. Okay, you can see that these are three words, 1 unit. 3 words, 1 unit. Pasta is not 3 words, 1 unit. Is not tasty, 1 unit. Pasta, it is not combining one single word and two words, right? It is only considering three words as a single unit. Okay, but in case of 1 comma 3, it is considering one as in the vocab, one word. Even it is combining two word. You can see there's some this pasta, it's a 2 word of combination and 3 words of combination. Okay, so this is how, depending upon this parameter, the count vectorizer from the same API, okay, from the same API, it is implemented both bag of word and gram. Okay, so this is the only difference, how it prepare the vocab size depending upon this parameter, and it will solve this problem of order, contextual meaning, negation, and uh, it will create the vectors. Okay, so in case of NGrams, your vocab size will increase. Obviously, it is called augmentation. We are combining multiple words, right? So we are augmenting, right? So our vocab size will increase, right? So you can see that in the trigram. Trigram is this, right? 1 comma 3, right? In 1 comma 3, right? So in 1 comma 3, these are the number of vocab, right? So vocab size will increase, right? Yeah. Okay, so this is how it works, my friend. I hope you got the understanding, and this is very useful in case if you really want to capture the word negation. Okay, and once your vector is ready, once you got the vector, then building the model is the same concept as we discussed in the last video. We did one project. So once your vectors are ready, just build your model, maybe random forest, whatever model you can build, and you can build a prediction. You can find the prediction based on the model. Okay, so only difference is that you are creating more vocab depending upon the NGram range, and you're capturing more nuances, more context in the given sentence, and maybe it will give a better result. Okay, let's suppose you're building a bag of word, you're not getting good result, then switch to NGram, maybe 1 comma 2, 1 comma 3, or 3 comma 3, and let us see how it is giving the result. Maybe your model performance will be better if you increase your word combination or augmentation, right? So this is how it works. Okay, this is the concept of NGram, and I hope I was able to explain you all the basic concepts and how it solved the limitation of bag of word. Okay, so this is all in this video, my friend. I hope you got a lot of idea about bag of word, NGram, what are the limitation of bag of word, and how NGram solve all the limitation of bag of word, how NGram is able to capture the contextual meaning, order, negation, and how you can improve your model accuracy if you're building sentiment analysis kind of model using NGram. Okay, in next video there's another technique of feature extraction, is called TF-IDF. Okay, I will cover in the next video what are the concept of TF-IDF and what problem it solve. Okay, so this is all in this video. I will see you in the next video. Till then, goodbye, keep watching and keep learning. See you in the next video.